of Waikiki. That's Diamond Head Crater in the background. And then 80 days later, that's me under the Golden Gate Bridge. I guess you could say it was a life-changing experience, and I think that the photos speak for themselves. So what I want to talk a little bit about is basically what the Vortex swim is, kind of how the expedition came about, what the goals of the expedition were, what we did out there, what we saw, and the takeaways. So hopefully we get all the way to the takeaways. We don't have too much time to talk. But I did also want to say, too, a little bit more about my background is I'm actually more focusing in the field of oceanography. I do have a minor in marine biology, but I'm more interested in how the ocean moves, how it controls global systems, and how plastic is being moved around by these ocean currents. And so the Vortex swim, why I was interested in joining the project was because it's all about how the ocean is accumulating plastic in this region and where, like how it's moving around. And eventually, like that's also how it's getting to Hawaii. So currently I am I'm just starting a master's degree at Hawaii Pacific University. And my master's thesis is on identifying the sources of the derelict fishing gear, otherwise known as ghost nets, that are washing ashore in Hawaii and up the archipelago. So the Vortex swim started with this guy, Ben LeCompte, right here. He was the crazy French swimmer who actually swam across the Atlantic Ocean in the year 2000. And it was kind of after that project ended 20 years ago, he was kind of like feeling like he wanted to do something crazy again. So he thought that he was going to swim across the Pacific Ocean. So they set out in 2018 to swim across the Pacific Ocean. This was kind of leg one of the longest swim expedition, they were calling it. So this is what the intended track was. If you can imagine where they started over there in Choshi, Japan. Ben was going to swim across the North Pacific all the way to San Francisco under the Golden Gate Bridge, set another world record. It was going to be awesome. Well, unfortunately, it's a little bit harder to swim across the Pacific Ocean than he thought, and they ran into at least two major storms and just terrible weather, a lot of problems. Had to end the swim early after some gear failures and ended up in Honolulu. So at that point, they already had this amazing vessel, I Am Ocean. They already had some sponsors for the Trans-Pacific Swim, and they already had a lot of support, but they were trying to reconstruct the project, and they were really interested in studying plastic from the beginning, and to reconstruct the project in this way, they were able to target the highest concentration of plastic in the world's oceans, which is the Great Pacific Garbage Patch, and basically just completely revamp the project to focus on this region and study it while Ben swam through it. So to make this expedition possible, it's such a unique experience. It required a crazy swimmer. It required a trusty sailboat. This is a 67-foot Challenger, obviously a monohull sailboat. It generated its own electricity. We had a diesel engine inboard as well, and generators, water makers, and a little research lab that was actually a toilet. Then you need a crew to sail the vessel and to escort Ben on his swim. So this is our crew here, and I'd love to introduce every single member of the crew. I think it's going to cut too deep into the time, but basically very multicultural group of people from Israel, Australia, London, Hawaii, and France, and just really great how we all came together. We had a bunch of different science partners, including Woods Hole, Oceanographic Institute, Scripps, NASA, University of Hawaii, Sea Semester, and then I got tangled into this mess because of my background working with marine debris. I was formerly working for NOAA as a marine debris technician and doing work up in Papahanaumokuakea. And when the opportunity came up to jump on board the Vortex swim, it fit really well with my experience. So pretty much jumped on board and had no clue what to expect, but we basically sailed from Honolulu all the way to San Francisco in 80 days. Now, I don't know if any of you are sailors, but I didn't really realize that 80 days at sea was a super long time to people that actually sail the world's oceans. After I got back, I was working a surf contest with Sustainable Coastlines, and I met this world-renowned sailor who has circumnavigated the world's oceans 3 times around. And he said that he's never been at sea for more than, I think, 35 days at the longest stint. So I was blown away at that. Basically, we launched in Hawaii right here on June 13th. And that's our track line. We have GPS track on us the whole time. And the hash marks in the middle there are what's known as the Great Pacific Garbage Patch. And every dot on the plot there is where Ben swam. So we're going to go through a brief overview of plastic. Basically, plastic comes from oil and natural gas extraction, and it used to be a byproduct of this process, but now it's actually becoming a primary product. A lot of these oil and gas companies are seeing plastic as the future of their profits, and as our gasoline consumption goes down, our oil consumption is going down with more innovations with electric cars and other transportation innovations. Also global warming. And these are pre-production plastic pellets. So all plastic items start out as these pellets. There's hundreds of different polymer types, different compositions of these pellets. We call them nurdles. And the crazy thing about these nurdles is you're going to find them everywhere. If you've ever done a beach cleanup, next time you're at Makapu, next time you're pretty much at any windward-facing beach, I'm sure you'll find nurdles there. These are plastic pellets that have made it into the environment before they were even turned into a plastic product. And it all kind of started in the 1950s when America produced a bunch of propaganda that was all about throwaway lifestyle. Now everything's disposable. You don't have to wash the dishes anymore. Your life's going to be way better now. And that leads us to 2020 when we're producing over 350 million tons of plastic every year. And that number is just it's just forecasted to go up and up, right? And so how much of that gets into the ocean? It's estimated to be about 3% of the total production annually, or about 8 million metric tons. That's 220 pounds. 8 million tons, and at 1 ton is 220 pounds. Or 2,200 pounds is a ton, metric ton. So it's a lot of plastic waste getting into the oceans every single year. That's equivalent to 1 garbage truck dumping a full load of plastic into the ocean every minute for an entire year. So it's definitely a lot of plastic getting in the ocean. These are recycling codes. Each recycling code indicates a different polymer. And the polymers that you're going to see in the ocean are not all of them, because a lot of plastic actually sinks. But where these blue arrows are on the bottom is going to be the polymers that you see floating in the open ocean. Polyethylene type 1 and 4, there's low density and high density. These are the types that a lot of commercial fishing gear is made out of. Polypropylene is less dense than water, meaning that it also floats. And polystyrene is actually denser than water, but most of styrofoam objects, including fishing floats and everything, are made out of polystyrene. And even PVC as well, if it's turned into foam. All right, so now this is kind of like, these are some everyday objects that are turned into plastic products that we found in the garbage patch. I don't know if you've done any beach cleanups, but toothbrushes and razors seem to be really popular items, disposable items made out of plastic that find their way into the ocean. And on the right are like fish baskets. This is a photo of a bottle cap, and to me, this was one of my favorite debris items that we captured in the whole expedition. And a bottle cap is only about an inch in diameter, but you can see that there's a whole community of life or marine organisms that have attached itself to this tiny little bottle cap, and it's created a whole community of marine life. So on the left is like some flying fish eggs. There's some other like bivalves, and then there's some bryozoan colonies and all kinds of microscopic marine life. And it just shows that like anything that you put into the ocean is going to be colonized as a habitat. You know, this is a region of the ocean. The garbage patch is a region of the ocean that's kind of like a desert, and there's not that many habitats to be occupied. So it's kind of interesting how life is interacting with plastic out there. Now, another thing that happens when plastic floats around or just sits in the natural environment for a long period of time is what we call photodegrades. Photo meaning the sun's energy, and degrades means it breaks down. So photodegradation breaks down plastics. It's based on the radiation, and it basically makes these plastics super brittle, and that's why you see a lot of fragmentation and cracking in the plastics. So you can have fully intact large plastic items like a water bottle or a fishing float or something, or any other plastic product. And then over time, it will start to fragment and break down. And that's where a lot of the sources of these microplastics that we're finding in all of our water samples are coming from. It's just degradation of plastics. Plastics also release a lot of greenhouse gases as they break down and degrade like this. So it's another source of greenhouse gas emissions into the atmosphere. And what this figure shows, getting a little heavy on the science side here, but this figure came from a publication that from Ocean Cleanup, and it basically shows that smaller plastics, which are represented in the micro scale on the top two panels, are much more abundant per particle per individual piece than the larger plastics, meso and macroplastics on the bottom right. So the darker red and orange is the higher concentration. And we're looking at the Pacific Ocean primarily. Now, if we're looking at plastics by weight, you can see that most of the weight of the plastic in the ocean is represented in the larger plastics, so macroplastics. And this includes like a lot of fishing nets, derelict fishing gear, and just anything that's larger than 20 centimeters across. And how does the plastic form into these garbage patches? So the Great Pacific Garbage Patch sits in the North Pacific Gyre up here. Hawaii's right here. California is over here. The North Pacific Gyre, it goes all around the North Pacific, but the plastic kind of congregates right about here near the California current, between that and Hawaii. And the reason why is because these gyres are large current patterns in all of the world's oceans, and basically the gyre pattern congregates plastic. The net transport of plastic or any debris or anything that gets into the ocean is going to be towards the center of these gyres. All right, so we actually have garbage patches forming in all of our oceans. It's just the most obviously prevalent in the North Pacific. And this is a plastic concentration map that was created by a physical oceanographer partner at the University of Hawaii. And we would get these maps like every week sent to us, and it would kind of forecast based on the currents where we thought the most plastic would be. And we would try to get there so Ben could swim through them. And I'll just play this for like 2 seconds, but basically here we are in the middle of the Pacific Ocean. It's probably 40 out there. We haven't seen it over above the weekend. Let's just swim away. And take anything away from this video, it's the ocean. So I just want to talk briefly about the science, and maybe somebody could give me a time check because I'm not really watching the time. So,
Drew, I think we've got about 5 minutes. I'm sorry to tell you that.
Yeah, no worries. It's pretty hard to fit a 20-minute talking hour talking 20 minutes, but we're doing our best here. So basically what we did is we collected microplastics using this little trawl there. We call that a manta trawl. We would attach it to a boom off the mainmast, and we would tow it for about 30 minutes.
The video is very loud, so we can't hear you.
Okay. Anyway, I was basically saying that's the trawl that we tow for to collect these plastic samples. So we would tow that trawl. It's called a manta trawl because it looks like a manta ray. And we tow the trawl for 30 minutes at a time. And in 30 minutes, we pull it up. We empty the contents of the cod end, and we pour it into this sieve. And the sieve drains into the water drains into the bucket at the bottom, and then we pick hand pick out the microplastics from the sieve. So this was our largest catch of microplastics. It was crazy when we pulled this up. There was over 3,000 pieces of microplastic in this single sample. And I was just collected in only 30 minutes of towing that net at like 1 knot or 1.5 knots. That's a little zoom up. You can see though, it's not just plastics. There's a lot of marine life in this, in the surface layer of the ocean as well. So it's really incredibly challenging to separate life from plastic, and there's no way to just skim the whole surface of the ocean with thin mesh, because we would kill all the life that supports all the bigger things in the ocean. So it's just one more complicated factor to get plastic out of the ocean. On that same day, we actually ran into a pod of sperm whales too. So highest plastic concentration zone, we're seeing sperm whales. This was a mahi-mahi that we caught. We were like fishing we were collecting data on fish to see if they have plastic contents in their stomachs. Do you think we ate this fish afterwards? Anyone want to comment real quick? The answer is absolutely we ate this fish afterwards. We were starving and our other options were terrible freeze-dried meals. This is a satellite image of our boat. We were trying to compare satellite imagery to on-the-water observations of plastic concentration. So this is kind of our partnership with NASA that we were working on. And that's a big ghost net with me underneath it. So we found a bunch of these. Not a bunch, maybe like 10 massive ghost nets. And for half of them, we tagged with really big, or we tagged with satellite trackers to track where they move, and also attached biological panels to see what's growing out there. And we had a lot of curious wildlife. These albatross would just come right up to us, and they are indiscriminate on what they eat. They have no taste buds, so it's no surprise that they're just eating this plastic right off the surface. This is a fish that is a coastal species. I have a cool video of that right here.
We're gonna cut it open and just kind of see. Like shake him out. There he is. Hi, little guy.
So basically that was a video of a frogfish, and I think this one, I'm not sure exactly where they come from. There are species of frogfish in Hawaii. I think this one might have been from, this was the most common one we saw. It could be from Japan and the kelp beds over there. But basically it's a coastal reef species, and we're finding it in the middle of the Pacific Ocean. It's way far away from where it's supposed to be. This is a sea slug that skims the surface of the ocean. Really beautiful. It's called like the dragon sea slug. And this image just shows like there's always a community of life supported by all these nets. So there's so much to be learned scientifically about the communities that these nets support. There's a lot of reason why fishermen like to fish off of these. That some of them, if they're put out intentionally, are called fish aggregation devices. And this is part of what I'm studying for my master's.
Hey, Drew, I think we're gonna ask if anybody has any questions to type in the chat. We've already got a question from Jenny, and she was asking about the types of nets that you found. Seems like that might align right now with your presentation. Maybe you could tell us a little bit about what kind of, did you find an abundance of certain types of nets?
Yeah, I know, it's a really good question, and maybe I wish I could see you guys too. I don't know how to see the chat.
There's like a little, if you click on the more.
I got it. Yeah, now I got it.
Okay. All right.
Yeah, so good question. I guess what kind of nets did we find is the big question. I guess it's really hard because a lot of it just looks like a bunch of junk lines tangled together, and there's actually no scientific, scientific evidence as to like what type of fishing gear is out there. So it's completely novel research, and this is the project that I'm taking on for my master's. So check in with me in 2 years, and hopefully have a couple of publications out by then, and you'll know a little bit more information as well.
Yeah, I think Peely also has a question in there. What was the most impactful and less expected finding of the expedition?
I think that I mean, it's crazy how jaded you get to this stuff so quickly, as sad as it is. And I think it just comes back around to like shifting baselines and where we want to draw the line in our lifetime. You know, we kind of have the responsibility that we know the impact that we're making right now, and we're kind of at a point where we can change it. But if we don't take action right here, right now, this problem is only going to get worse, and the ecological impact is largely unknown how bad it can be. But I think that the scientific community collectively feels like it's not going to be, it's not going to be beneficial to life on Earth. So I think that the most impactful thing is just like every morning I would wake up, walk out on deck, and first thing I'd see, I wouldn't even have to like look on the horizon. I would see plastic like all around, you know, and just to see the scale, like thousands of miles from civilization, how much plastic is in the ocean is pretty heartbreaking. You know what I mean?
Yeah, it's crazy.
Jacob says,
I
I've
think
seen frogfish on most of the nets I've picked up at C2. You know if they're mass spawners? What is their dispersal strategy? Is it? Good question, Jacob. I'm not a fisheries biologist, but I would guess that they probably lay eggs on the debris, and the debris drifts out to sea, and then they hatch, and all they know is the debris. That's what that video of the frogfish getting cut out of that bottle. It was clearly that frogfish found that bottle at a young age and grew so big inside that bottle that it couldn't ever get out of the bottle. So I think that's kind of how they're getting out there. Can I play the videos without audio?
If anyone has any other questions, you can unmute yourself and ask.
Yeah, I'd like to talk to people. It sounds fun.
I think Scott had a question.
Scott.
Yeah, I can go ahead and ask it instead of you reading it. So, regarding your thesis, Drew, like, so regarding like ghost nets and everything and where a lot of the plastic pollution is coming from, it likely comes from a lot of different resources or like a lot of different sources around the world. How are you going to go about like identifying where those actually come from? And not only that, like they have to come from probably either an industry or a distributor or something. So how would you, go about like enforcing, or what would you do with that? Like.
Yeah, it's super good question. And I think that, so basically the approach that we're taking for this research project is looking at it from the gear that we're finding, and then we're trying to kind of backtrace it, kind of like plastic forensics is kind of like the term in the field. So basically trace it back to where it came from by recording the identifiable characteristics about it. So what I mean by that is, like, if it's a net, I'm going to measure how thick the opening of the mesh is, and how big the meshes will tell us kind of what size fish can fit through it. Also, by knowing how the gear is constructed, whether like how thick the other lines are attached to it, or what kind of floats are attached to it. We hope to be able to identify, by taking a more holistic approach to each debris mass that we find, we're hoping to be able to identify it back to a specific fishery, and then basically work with fisheries experts. We're not going to be doing the identifying. I'm just collecting the data on the nets, recording all this information, taking photos of it, and then we're going to be working with fisheries experts. So if you know any fisheries experts or expert fishermen, contact me, please, because we're looking for some to do a survey in a few months, or possibly this time next year.
Hey, Drew.
Yeah.
As I'm kind of a designer, and we're also, obviously very concerned about the environment, and we're trying to use plastics that aren't impacting. And I know there have been a lot of new kind of plastics out there that are not oil-based, such things like polylactic acid, which are based from corn. Interestingly enough, the polyethylene that you were showing, there are products out there that are based on soy. And you may not know anything about it, but I wonder if you have come across anything that is showing plastics that are, let's say, better to be used in being biodegradable for the ocean.
Yeah, absolutely. Great question. And I'm really glad you asked. I hope I don't break your heart right now. But I'm going to tell you that all those plastic products are complete greenwashing, in my personal opinion. None of them are biodegradable, or if you threw them out in the environment, they would be out there for just as long as normal plastic polymer. All they're doing is basically creating plastic polymers from natural resources versus oil and gas extraction, and creating the exact same polymer. It's not going to break down in the environment any faster or any better. And I would say avoid at all costs. It is not recyclable. It is not compostable. It's just a terrible product. Stay away from it.
Wow, that's fascinating.
But
It's very good to hear that.
I will say though, like that's just a common misconception, and it's just where our economy is at in the process. I'm super optimistic that we are going to create products that are very compostable and just as applicable to the needs that these current products that are not biodegradable and are causing so much plastic pollution. I think that we will get to where we need to be, hopefully sooner rather than later. There's tons of innovations going on all the time. And really just if we can find products that we don't have to alter so much in the creation of them, then those are going to be the ones that are going to break down naturally. If you have to heat something up basically if you have to heat something up or pressurize something or synthesize polymers to create it, it's not going to break down naturally. You're going to have to do the exact same thing to break it down.
All right. Well, thank you, Drew. I really wish we had like way more time, because I think we could just go on for hours talking about this. And I definitely think I would love to speak with you in the future. I think definitely Eco Rotary would love to talk with you more in the future, especially about our beach cleanups and how we can be better at that. So I think Peely is gonna end.
I just want to say too, I put it privately accidentally, but I'm gonna put my email in the chat so that if you have any questions or any follow-ups, or you want me to do any more talks or talk personally, you can go ahead and email me, and I would love to just talk story, get to know you guys better. Hopefully we can do this in person one day. Yeah, thanks you guys for having me. Appreciate it, and hope you learned a couple things.
Yeah, thank you, Drew.
Thank you for joining us and for explaining us. It was very, very interesting, and many things that I didn't know at all. And I'm sure that everyone. So before we go, like, if anyone has questions at all at this point.
I do have one last question for Drew that I'm kind of curious about.
Go ahead.
Yeah. So I have heard through plastic pollution and everything, and it getting into our ecosystem, and fish eating it, and humans, eating fish and everything. Like, how much, or if any, or what do you think? I mean, is plastic pollution getting into the actual like human population by us eating these fish and these fisheries when they're in the ocean that have plastic pollution in it?
Yeah, it's a good question. I actually don't know the latest findings on as far as fish that we are eating finding plastic in their tissues. I know that we're finding plastic in fish stomach contents quite frequently, and I would love to do a search on the latest scientific findings on this. So that's a really good question. I'll get back to you on that. But as far as like plastic in our bodies, like we know that we're finding plastic in human tissue and human bodies in our bodies right now. Even I think as small as in our bloodstream, and a lot of this is coming from microfibers, things that are like things such as car tires, even the dust from car tires on the roads, and also from microfibers of polyester clothing. So if you want, like anytime you do a load of laundry, it puts like hundreds of thousands of microscopic fibers into the water system, and those fibers are too small to be filtered out. And so we're finding these fibers in our drinking water and stuff too. So It's pretty freaky. I'm sorry if this is too much for you guys, but it's a reality, and I think it's important to know about this stuff. And I hope that that we find some solutions quick. It's definitely the need.
Absolutely. Thanks.
Thank you so much. So now I'm gonna unmute everyone. So before we move to the next and last point of the meeting, I wanted to thank Drew for his very informational presentation, very enlightening. I think that this subject is something that we all should be more aware of and learn more about it. Because, you know, like, there is always this generational thing, like, oh, the kids on the plastic, and because it's just been like a systematic problem over the years. And it's not like a young generations have it's right and old generation is not right. It's just been like part of the business model that has been leading society for a while. And it's not bad. It's just that it's not good for a sustainable future. So I think that it is very good to know that that the conversation start and that we actually need to make some changes in the way that we behave and in the way that we consume. Before we used to think, like years ago, my parents used to think that resources were infinite, right? But now we're finding out that that's not true, that we actually need to take action and that those behavioral adjustments start at home. So thank you, Drew, for joining us. Thank you for giving the talk. And it is very interesting.
Yeah, well said, Pilly. Thank you so much. I really appreciate that. It's a great closure, and there's, you know, these big topics are overwhelming, but all we can really do is what we can control. So I think we all have our part to play, and collectively we will make a difference for sure. So
absolutely. So thank you to Guando and Skip to join. Thank you for Drew's support crew. I got to know them, your entire family in the breakout room. Thank you, Arlene, Sonia, Rogie, and all those members from different clubs joining. Thank you to Grace, Richard, and Angela from Kenya. So actually in Kenya, it's morning, 7 in the morning. So they just joined, they just woke up and they joined our meeting. So I really appreciate it. Before we go, Frida is also here from Kenya. So thank you very much, guys, for joining. Before we go, we would like to close with a 4-way test, because that's the way that we close our meetings. So I will have call Jenny so she could lead us in the 4-way test.
Okay, so you can all repeat after me the 4-way test of what we think, say, or do. 1, is it the truth?
Is it the truth?